Okay, so we've got an object of mass 4 kilograms is moving along a horizontal surface by means of a string. So let's just draw this horizontal surface, because in part A we're asked to draw a force diagram identifying the forces in all directions. So if we have our object moving, okay, on a horizontal surface, we'll just draw my object here. Okay, now suppose we'll always assume it's moving to the right, okay, so it's going in this direction. So we need to then have an arrow to show the direction it's heading in. So we double arrow there to signify the acceleration. Okay, so we put A there for acceleration. So it's accelerating in that direction. The reason why, of course, is because it says here that this object is being pulled by a string, okay, and the string, it says, is parallel to the horizontal surface. So when I draw my string attached to it, it's being pulled in the horizontal direction, and we've got tension T in that string. So it says here to draw a force diagram. That's the first force we need to perhaps consider there, the tension in that string pulling it along, okay? It also says, given that resistance to motion is 8 newtons, and the object is accelerating uniformly at 0.5 meters per second squared. So we've got the acceleration there to be 0.5, but it's got a resistance to motion. So if it's heading this way, but there's a resistant force pulling it back, holding it back. So that could be anything. That could be air resistance, okay, could be the friction, the contact of the surface, but they're saying that the resistance to motion here is 8 newtons. So I'm going to write the force of 8 newtons here, which is opposing the direction that it's heading in. So of course it's going that way, it's being pulled by the string, but there's a resistance there of 8 newtons. So we've got the horizontal forces. There's also vertical forces, of course. So we've got the weight, okay, acting on the object. Now the weight, of course, well, because the mass is 4 kilograms, the weight then will be the mass, which is 4 times the value of gravity, g, okay? So it's always the mass times g. There's another force we need to consider as well. If there was just the weight, if there was just this vertical force of the weight, then we'd expect that object to just fall, yeah? The object to fall, but it doesn't fall, doesn't it? It stays on this horizontal surface. The reason why, of course, that it doesn't just keep falling is because this surface is supporting it, okay? So what happens is, with the weight, the surface reacts. The surface is strong enough to keep this object in place, so it reacts with the force R, okay? So it's like pushing it up, it's holding it there. If the road wasn't strong enough, the object would just go through the road, wouldn't it? Okay, right, with the weight of that object there, but it's strong enough to hold it. So, draw a force diagram identifying all the forces. We've done that. In B then, determine all the forces acting on the object. So first of all, we're going to consider in the horizontal direction, and we're going to apply Newton's second law. So Newton's second law, so we can put N to L, okay, Newton's second law in the direction of motion. So of course it moves this way, doesn't it? Horizontally. So when we think of Newton's second law, we think about F equals ma, but more specifically we should think resultant force equals ma, okay? So even though we learn F equals ma, which is correct, the F is actually the resultant force, the overall effect. So the overall effect would be the fact that we've got this tension here pulling it, but working against it is the resistance of 8. So the overall effect is the T take away 8. That's the overall effect, isn't it? So tension's going to be greater than the 8 because it's able to pull it, but the 8 is working against it, so it's taken a little bit away from this tension, isn't it, to create this resultant force. That will equal then to the mass, which is 4 kilograms, times the acceleration, and the acceleration we told is 0.5. So we've got T take away 8, and 4 times 0.5 is 2. And then if we take that the other side to the opposite, so we get then T is equal to 10 newtons. Okay, so that's the force for T. Work that out. For R, so we're going to work out the value for R here, the reaction force. Well, of course, they balance, don't they? So when we resolve vertically, We could apply Newton's second law, but there's no acceleration because it stays there, it's balanced. The floor is perfectly balancing the weight of this object, so we can simply say, resolving vertically, R is equal to 4G. Okay, they balance there, so we've got balance of forces, so R will be 4 times 9.8, and we get 39.2 newtons.